Let's talk about data, graphs of data, and relationship between two variables. I don't want to miss any words, so I type them all out so you can take a good notes. A set of bivariate data, the bi means there are two variables in one set of data, is recorded in the following table on your left side. So there is a pink table. The first variable, the first column, represents a student's final exam score. The second variable, the second column, represents a student's research paper score. So each line stands for one student. So for example, if you take a look at the first line, the 7265, we have a student got 72 points on the final, and the same student got 65 points on the research paper. And then the next line is 7570. The second student got 75 points on the test and then 70 points on the paper. And then the third student, 7975, the third student got 79 points on the test and then 75 points on paper. So we have 8 students. Each student represents one dot on the graph. So on the graph, you see two axes, right? The horizontal axis is represent final exam. The vertical axis represents research paper. And then I scale the horizontal and the vertical axis. So the first student, 7265, is the one dot on the picture. So where is that dot? So when final exam is equals to 72, do you follow my yellow dots? So it is right here. So we have the first student got 72 points on the test and then 65 points on paper. So 72, right? And then 65 point is right on the horizontal axis. So this is what we have. And then the next student got 75 points on the test and then 70 points on paper. The next student got 79 points on the test and then 75 points on paper. The next students got 81 points on the test and then 80 points on paper. And then the next one, 84 points on the test, and then go all the way up, got 98 points on the final, so on and so forth. We have 8 students in this data set, therefore we have 8 dots on the picture. Every dot stands for one student. All right, so what is the benefit of constructing this graph? So let's say you don't have 8 students. Instead of having 8 students, you have 80 students. So that means you have 80 points, right? So if you just look at the table, you have 80 pairs of number. It is hard to tell any stories between the two variables. You have 80 pairs of paper or 800 pairs of paper. 800 pairs of data, not paper. It is hard to tell the story or the relationship between the two variables. But if you construct a graph, instead of using 8 pairs or 80 pairs or 800 pairs of data, you have a graph so you can see the overall pattern of the dots. So the benefit of constructing the graph is you can see the relation or the relationship between the two variables. So we have two variables. So with the x-axis is the horizontal axis, so right over here. And then that represents final exam score. So that is called independent variable. The independent variable is final exam. We use independent variable to study the behavior of research paper. And then what about the vertical axis? The vertical axis is the y-axis that represents research paper score. So this is an independent, this is a dependent variable. So research paper, the vertical is dependent, horizontal is independent. A student's research paper depends on the final if you put the graph in this way. So you have the research paper on the vertical axis, the y-axis, we call that dependent variable. So let's say you are in this class, I can say your paper score depends on your final exam scores. And then we have a comparison between algebra and statistics. So in algebra, x is called independent variable, but in statistics, we don't use the word independent, we use the word explanatory. And then in algebra, y is a dependent variable. In statistics, we call that response variable. And then statisticians use independent variable to study the behavior of response variable. So I type all this out so you can take a really good note. You can either take a screenshot or you handwrite everything over to your notebook. Okay, so that is the first example. Let's take a look at one more graph. So this graph, the data contains the number of complaints and quality rating of 10 coffee shops in the city. So how many data do we have? 10 coffee shops, so we have 10 dots, right? That means we have 10 pairs of data. So the first pair of data is right over here. So that means the first coffee shop has 0 complaint and the quality is 10, so pretty high quality compared to the rest. And then the next coffee shop has 2 complaints and the quality is a little bit lower. The next shop has 10 complaints and the quality is so low. And then the next coffee shop doesn't have too much complaint and the quality is pretty reasonable. So for the first one, when complaint is equals to 0, so complaint is equals to x, quality is equals to y, so that's why we put the x in the horizontal axis, number of complaints. Do you see that I label both axes when you do data? So let's say you are doing statistics in real life. When you show people the graph of data, you cannot just use x and y, because if you use x and y, they don't know what x means. So instead of using x, give it a name. So number of complaints, when I see these 3 words, I know what it is. When I see quality rating, I know what it is. But if you say y, I don't know what y is. So in algebra, yes, you can use x and y, but when you show people something in real life, instead of using x and y, you have to use some real names. So when you look at a newspaper magazines, you don't see a graph with x and y in it, right? They always label everything for you. Okay, so the first one, 0, 10, when x is equals to 0, the number of complaint is equals to 0. Do you see the origin? Follow my blue dot right here. Do you see this origin? When number of complaint is equals to 0, you look all the way up. The quality rating is equals to 10. And then the next one, when there are 2 complaints right here, horizontal axis, 2. And then the number of complaint is 6. And then 10 complaints, so that is all the way on the right. Horizontal axis, x equals to 10, and then there is the quality rating is 1. And then the number of complaint is equals to 3, so x-axis is on 3, and then the quality rating, you look all the way up to 7, and then so on and so forth. So we have 2 variables. The horizontal is number of complaints, and then we call this the explanatory variable, or you can call this independent variable. And then the vertical axis, the quality rating, we call that response variable, or you can call that dependent variable. So that means we say the quality of a coffee shop depends on the number of complaints. All right, quality depends on the number of complaints. Y depends on x. Okay, so what is the benefit of constructing this graph? The benefit of constructing this graph is we can see the relation between these 2 variables, complaint and quality rating. And then I mentioned that it looks like the points fall into a linear relationship, right? So linear relationship means this pattern looks like a straight line to me. A straight line looks like this. That looks like a straight line to me. So that's why I say there is a linear relationship between number of complaints and quality. So again, if you want to see the big picture, the relation or relationship, you have to get the graph. If you just look at the data, it is extremely difficult to tell any story or any relation between the 2 variables. So what if you have 100 coffee shops? You have to look at 100 pairs of data. It is impossible, almost impossible to tell anything, because there are too many numbers to process in your mind. But if you graph the data, you can see the big picture. All right, then after constructing this graph, I can see the big picture, so I can tell that there is a linear relationship between the 2 variables. So this, we already covered that. So x is the independent variable, explanatory variable, which is the number of complaints. The vertical axis is y, dependent variable, also called response variable, that represent quality rating in this problem. And then we are trying to use x to study the behavior of y. You can say the y depends on the value of x. All right, so that is the basics of relation between 2 variables, data, and their graphs. So if you think my instruction is helpful, give me a like, share the video for me, subscribe to my channel if you are on your way out. I will catch you all in the next lesson. Signing off for now.